Good evening. Pre-calc, we are on the 7th, so that's Tuesday, and we are looking at exponential functions that display growth and decay. And tonight, I just want to fill in a worksheet that I handed out today. So if you would get the worksheet, if you don't have it, you can just jot down the questions with the answers. Here it says, all exponential functions are of the form y equals ab to the x. So let's get that in there, ab to the x. So anytime you have this model, you have an exponential function. Now, we've been working specifically with one that had continual growth and decay, and that followed a sub t equals a sub o e to the kt. So this follows this pattern. This takes the place of this constant. Our b is 2.7 and our x is k times t. So this follows this pattern, and they're both exponential functions. Now, what values of b? So I'm particularly interested in this value right here. That's the one to which the exponent is applied. So over here in our daily work, we've been looking at it as e, but it doesn't have to be an e. It can be any constant. So what values would make the exponential function be a growth function? So a growth function will have a low, if we're looking at this from left to right, it'll start low and go zinging up. So that's exponential growth behavior. For that to happen, this value b has to be greater than 1. Greater than 1. As you can see, e, which I have mentioned many times, is approximately 2.7, is greater than 1. So we'll have growth. It'll be go start low and go zinging up. All right. So what values of b make it an exponential decay function? So again, our i's are right here. And we're looking at b. And again, we're going to see its behavior. For decay functions, b has to be between 0 and 1. So we have b is greater than 1 for exponential growth. Numbers like 2.7, 4, 100. But when we have exponential decay, so this time, looking at it from left to right, the function starts out very high and then comes low, like this. So the function starts, and the zinging upside is very high, and then it comes and peters out. We call it it tails off, the tail right here. So this is exponential decay. That will always happen when this value in this position, the b position, is between 0 and 1. Those are proper fractions like 1/2, 1/3, 3/4, etc. This e will never create an exponential decay function because it's greater than 1. All right, growth and decay. So on the next section, you're asked to sketch an exponential growth and an exponential decay situation. So I already did that for you up here. Remember, they cross at this point on each of them, the 0, 1, and exponential growth, something like that, and exponential decay. All right. For both, these are asymptotes. The function will get close to the x-axis and never touch it. All right. Now we're going to label each function as either exponential growth or exponential decay. The way we will know is from this information right here. If the number in the b position, that's to which the exponent is applied, There's a little exponent there. Can you see it? That's an x, very small. That to which that x is applied is the b. If it's greater than 1, we know it's exponential growth. If it's between 0 and 1, it is exponential decay. So that's all there is to it. So, looking at these pictures, indicate for yourself, is this exponential decay? We're always going to look at it like we're reading a sentence from left to right, left to right, left to right. All right, this one is starting high and ending low. High on the left, low on the right. So this is exponential decay. This one starts low on the left, high on the right, exponential growth. And this one, high, low, decay. All right, now for the mathematical formulas, label each function as exponential growth or exponential decay. So here's where the eyeballs go, right here. If that number is greater than 1, we say exponential growth. So growth, exponential decay when this number is less than 1, and between 0 and 1. And this one, 5 halves. 2 goes into 5 2.5 times, so that's definitely greater than 1. Alright, we have a few more to do. Do those. Then look at my work and see if it agrees. Alright, check it with mine. Greater than 1, growth. Less than 1, decay. And greater than, between 0 and 1, between 0 and 1, decay. Okay, that's all there is for tonight, because we need more time in class to add to our exponential equations some logistic growth and the Gaussian curve, and some other functions that have logs in them. Alright, so we'll be working on these kind and those additional kind, and finish up actually our whole section, and we will be ready to start reviewing for a test. So this is the last topics. Alright, not much for us tonight because I want our classwork to catch up. So in doing so, we will be ready for a test. Talk to you tomorrow about that in more detail. Be thinking what day would work for you in the near future. All right, good night.